Okay, Ji, so can you hear me?
Yes,
Yes,
sir.
yes.
Yes,
Okay,
sir.
sorry for interruption because there was some problem in the electricity, right? So we are back. Okay, Ji, so we were at the point. Okay, Ji, so we were at the point where we had okay, Ji, we were at the point where we were have the diode as behaving as reverse bias, right? So when the diode is behaving, Ji Sakib, Ji,
सर टेबल लिंक राशन के
सर
The
को
यार
जान म्यूट करो
the internet मसला था bro the दिख
सर लाड़ो
जाने म्यूट को यार
वालो यार
प्यारा
वापस
जी
start
या मेरा तुम पर क्लास के
हाँ उस रालम
स्पीक है करना
ना
सर रोहल अमीन चलेगा प्लीज
ब्रो ब्रदर वो को कंसोल बना ना कोई यार
please behave yourself you have elders in your
Excuse me, sir.
जी वो है
हाँ भाई सर का इंटरप्शन हुए थे क्लास होना स्टार्ट किया दोनों
ये 2 मिनट वेट ओके
हाँ जी सही
Okay,
है
sir.
सर ठीक है
okay जी so we are back can you hear me now
Yes, sir.
Yes,
clear
sir.
Yes, sir.
okay so kindly turn off your mic please okay so we were at the point when the diode became reverse bias right so once the diode became reverse bias the circuit will look like let me redraw the circuit the circuit will look like we have V naught across the resistor. We have Vp, which is the charges which are accumulated across the capacitor, and we have the input Vi. Now the diode has become an open switch, and we are at the point where the input signal is actually now going from the input signal is going from negative half cycle to the positive half cycle like this, right? Are you with me?
Yes, sir.
Okay,
Yes, sir.
so when the input signal is going from negative to positive half cycle, so this means the this end of the input source will become positive and this end of the input will become negative.
आवाज नहीं है
No problem.
Acha ji, okay. Can you hear me now?
No, sir.
Okay, so when we are going from negative to positive half cycle, the input voltage source will have these directions which you can see on your screen. The input voltage source will have these directions once we are going to have the positive half cycle, right? Are you with me?
Yes, sir.
Yes, sir.
Okay, so once the diode became reverse bias, so this means the within the circuit, it has no role now to play as long as the input voltage source is in the positive half cycle, right? So,
Yes, sir.
so what we can do to make the circuit more simple, that we can actually remove this leg over here, right, from the circuit. And this is the circuit which is left with us once we are in the positive half cycle, right?
Yes, sir.
So if you see, the capacitor can now discharge through the resistor, but as we know, the value of resistor is R and it is apparently quite big. So what we expect, that the capacitor won't be able to discharge very quickly, because the time constant in this specific case, C into R, where R is this capital R, the time constant through which the capacitor is going to discharge, is C into the capital R, right? So C into capital R, this means that the time constant is a big value. And when the time constant is a big value, so discharging will take a longer time. And once the discharging will take a longer time, so this means that the capacitor will hold its charge, right? And if the capacitor is going to hold its charge, so what we can do, we can apply KVL to this circuit, right? And if we are going to apply KVL to this circuit, so the equation which we are going to get, it will be, just let me draw the equation, write the equation, and then we will. So the equation will be, if we are going to look back into the circuit, so we have the circuit, it is going to be V naught should be equal to the drop across the capacitor, which is Vp, plus the input signal, which is Vi. Are you with me?
Yes, sir.
Yes, sir.
Okay, Ji. So once this is the case, so we can see that the input signal can have a maximum value which will be equal to, we can say the maximum value is equal to Vp, right? The maximum value of input signal is, as we know, it is equal to Vp. So if we want to find the maximum output value, which is going to be, we can say, if we want to find the maximum output value V naught max, it will be equal to Vp plus the maximum input value. The maximum input value is, if you see from the sinusoidal waveform, it is also equal to Vp. So what we can do, we can replace the input Vi with its maximum value, which is equal to VP, right? Are you with me?
Yes, sir.
सर ये रिपीट कर दें.
अच्छा जी.
Yes, sir.
Okay, so again, looking back into the circuit, we apply KVL. We apply KVL. Right? When we apply KVL, Usama, yo minute udrega. When we apply KVL, we get the equation V naught should be equal to VP, where VP is the drop across the capacitor plus the input voltage source, right? So applying KVL, V naught should be equal to VP plus VI. Now, if we want to find the maximum value across the output, so for that, we will look into the maximum value of the input, where the maximum value of the input is also VP. So what we can do to find the maximum value of V naught, which can be written as V naught MX, is it should be equal to VP, where first VP is the drop across the capacitor, and the second VP, which is being replaced with VI, which shows that VP is the value which is the maximum value of the input, right? So therefore V naught max will be equal to 2 VP, right? Are you with me now?
Yes, sir.
Yes,
Is
sir.
this thing fine?
Yes, sir.
Yes,
Yes, sir.
And similarly, if I want to see what is going to be the minimum value of V naught, so what we can say, V naught minimum should be equal to VP, and if you look at the sine waveform, the maximum value is VP. What is the minimum value of VI?
Minus
So this means it is minus VP,
VP.
right?
VP.
So if we are going to write V naught minimum, so it should be equal to VP plus, in the bracket we can write minus VP, right? Are you with me?
Yes, sir.
So this means
Yes.
V naught minimum should be equal to 0, right?
Yes, sir.
And if we want to draw this thing, we can draw it like we have 0, we have VP, and we have 2 VP. So this means the input is varying in between VP to 2 VP, and then from VP to 0, and then from 0 it can go to
Some
back to,
problem.
okay, you will see now. So if you see, the input is going to vary in between 0 VP and 2 VP, right? So the input is going to if you see, the output is going to vary in between 2 VP, VP and 0, right? So this will be our V naught. Are you with me?
Yes, sir.
ठीक है जी?
सर जी वी नॉट क्या है सर? वी नॉट
V naught is basically the, if you see in the circuit, V naught is across the resistor, right?
सर ये ड्रॉप नहीं होगा?
किस तरह ड्रॉप होगा जी?
सर रजिस्टर के क्रॉस।
अगर आप KVL लगाएं, so what you will see that V naught should be equal to the equation which I have shown you. V naught should be equal to VP plus VI. Are you with me? जी अफसर साहब,
Yes sir, now I get.
you get it?
सर ये सर ये नेगेटिव हाफ साइकिल नहीं है सर, इसमें हाफ पार्ट
जी क्या कह रहे हैं आप?
साउंड प्रॉब्लम।
जी आप क्या कह रहे हैं? क्वेश्चन? क्वेश्चन? जी अफसर साहब। जी
सर ये जो आउटपुट पे सर ये आउटपुट वेवफॉर्म है वो बिल्कुल इनपुट वेवफॉर्म के नीचे ड्रा करें।
okay, the thing is because
तो
we,
उसमें मैं पूछ लूंगा।
if you see, if you see, there is basically a delay from that one, right? So as long as you are in the process, so what you see that
साउंड
सर
प्रॉब्लम
वॉइस
सर।
प्रॉब्लम है सर, आवाज नहीं आ रही।
अगर आप यहाँ पे देखें, so you have a circuit which is now left with a capacitor, a resistor and an input voltage source, right? So with this you can apply KVL to the circuit. When you apply KVL to the circuit, so this means the capacitor is now working as a DC source which is holding the value equal to VP, right? The capacitor is working as a DC source which is holding the value equal to VP. Now once it is holding the value equal to VP, then after that whatever there is a variation in the input, that is directly reflected at the output. So the capacitor is just working as, if you see in the waveform, if you can see in the waveform at the output, we have VP, right? So this VP is basically the charge which is being accumulated across the capacitor, right?
Yes sir.
And this capacitor apparently seems to be a DC source in the circuit, which is holding its charge equal to the value VP. So now whatever there is a variation in the input signal, that is directly reflected at the output with a variation from 2 VP to 0. Previously, if you see, previously, if you see, we had the input signal which was varying in between 0 to plus Vp, and from plus Vp it was varying to minus Vp. So what is actually happening over here? What is actually happening over here is that we are shifting the DC biasing of this circuit with a value equal to Vp. So now the signal has been shifted. Now the signal. Okay, so now if you see, can you hear me? Okay, Ji, can you hear me now?
Yes, sir.
Yes, sir.
Okay, so we were talking
Yes,
about
sir.
that the signal has been shifted from the zero axis to Vp, right? And once the signal has been shifted from zero axis to Vp, this means the output is actually looking like this, right? ठीक है जी? Are you with me?
Yes, sir.
Okay.
Yes, sir.
Okay, the session is now going to stop for 10 minutes, because in this 10 minutes we will do the recording of the session. ठीक है जी? And then you log in after 10 minutes, right?